Hello and welcome back to the Automation Insider. I am Joe McGrath, your host and solutions development lead at Hy-Tek Intralogistics. I think about design a lot. I try to think about it a lot. I design a lot of things a lot. And every so often along my journey, I meet people that have a completely different perspective from myself, and we're both pursuing the same solutions to the same problems. And to that end, I'd like to introduce Emmanuel. Emmanuel, tell us about yourself.
What is up? Long time no see, Joe.
Yeah, it's been years, 7 years since we started working together.
Yeah, well, can we talk about where we met?
Yeah, well, I think we can talk about that. Yeah, we met when we were both working at Amazon, and you told me that you designed like roller coasters or like parade floats or something, and I said, "Oh my god!"
This is actually important because it's a little insight into the entertainment industry that I think most people don't know. Automation, if you walk into a warehouse and going to a Red Hot Chili Peppers concert are roughly the same thing technologically. It's crazy. Like the entertainment industry is using all the what you see in an Amazon warehouse is exactly what you're going to see at a Taylor Swift concert, which is
So a VRC is what's bringing Anthony Kiedis up onto stage. It's like the same
close. So
motor.
all of the motors in the control are the same. Like they all use Modbus or EtherCAT or whatever, and they have PLCs, which the technicians are actually controlling all of this stuff through. But all the logic, like the PLC and everything, exactly the same. It's crazy. And as an engineer, it actually going to Amazon was super easy because it was like, oh, I already know this stuff. You know what I mean? Like I know how to spec a motor. I know how to make sure that I have the right sensors for this thing, that kind of thing.
Yeah, it makes the box go real fast. There's no person on the box most of the time.
Yeah. Well, what's fun is what else? What other alternative would there be? Right? Like the Macy's Thanksgiving Day Parade and moving a box through a warehouse are roughly the same thing. Like they're tabletop to large scale, like a room size thing. The cost constraints are roughly the same. Actually, obviously, the parade was very cost conscious because it's one event a year, and it's on screen for like 10 seconds. So there weren't millions of dollars, but you kind of get where I'm going with that. So, but yeah, I mean, it's crazy. Like, what other alternatives are there? Like when you go to the size of an iPhone, then you're getting to, okay, well, this is a totally different technology stack because, we're designing systems on chips, not, elevators. So, but anyways.
So tell everybody like some of the places you might have worked and some of the experiences you might have had, like super high level. Give them some context.
Yeah, so I got my degree in mechanical engineering and then went directly into entertainment. And so I worked at a company called Tate, and there I designed automation machinery for stages, for theme parks, that kind of thing. So if you ever went to, like a Lady Gaga show in 2016, it was my stuff up there. When I say it was me and 10 other engineers, but you get the point. And then I went to the Macy's Thanksgiving Day Parade. I was the engineering director there, the first one to actually build out the engineering department. And so I was actually the first one to slap a PLC on something and say, "Behold, like you don't
automation.
You don't need a Scottish yoke to control a multi-axis move. You can use this thing called a computer." And boy, was that tough. Yeah. What's fun was I thought the hard part would be technological. Like, so let me give it a little context. The parade studio had never had an engineer before. Like they'd had one, but they left, and really they never did any like engineering documentation or calculation or anything really. It was more of like I never totally understood what that person did, but so I was there to like essentially bring it up to the 21st century. And what I thought would be the hard part was the technology, like building out the technology. That wasn't the hard part at all. The hard part was, okay, I bought a PL. First of all, actually, no, let me take a step back. Where do you buy it? Like, hey, I work for Macy's. You might have heard of us, but we don't have an account with you. So I need to buy this. And they're like, okay, well, you need to spend $10,000 before we'll even talk to you. It's like, okay, well, I need one of the thing, right? So that was part one. Part two was no one knew how to do any of this stuff. Like we had electricians, but they were literally electricians. They weren't industrial automation control technicians. You know what I mean? So the second thing I did after tricking a company into actually selling us something was I had to actually find somewhere in the country we could go get trained up on the equipment on. So
Okay.
I had to like pick 4 random people I thought would be willing to do the work, and then we went to this place in New Jersey and actually got trained to actually write, ladder logic. Just anyways, the point I'm getting at is that whenever you're if you're listening to this podcast and you're going to join another company to bring them up to a certain technological standard, do not forget that it's not just a technological problem, it's also a people and educational problem and cost problem. Yeah. So
I think it's the salient points. Like we kind of struggle with, like we're an integrator. We have basically the people that are all trained to do that stuff, and they sort of exist in this like little microcosm, at least for the supply chain world. And anybody that tries to go kind of self-perform immediately runs into like, well, how do you do the software for this? Well, that's a rabbit hole. Well, how do you do the controls for this? Well, do you have an electrician who can do this? I've seen people hire plumbers to try to like put in some of their equipment and just go, man, like there's a better way to do that. But it's like how do you get enough people that know enough about like really niche technology to get against someone?
By the way, this is why when people talk about reindustrializing the country, it's not that we don't have the technology, it's that we don't have the people. Like,
yeah,
like when you walk through, I'll never forget this. I was in Shanghai when I was working at Apple. I was on the iPhone team, and we had builds. I think it was mine was in anyways, I was in Shanghai for some reason on the weekend, and as I was driving in, I looked up and I saw a billboard. In Joe McGrath, I shit you not, there were automation equipment advertisements on the billboards. So it made financial sense for them at SEW or whatever it was to say, let's put up a big billboard of a sweet looking gear motor, because the return on that investment is going to make sense. Like that's the country, like that's the culture there, right? Have you ever seen a billboard advertise a PLC or any industrial automation equipment? Like, no.
I've seen billboards advertise other billboards in like rural Indiana. That's a pretty common one. Not a lot of traffic there though either.
So it's a people problem. Like we got to train these people. I mean, how do you even get trained as an industrial automation technician? Like, is there even a school for it, or do you just have to go trial by fire?
It's just a series of mistakes, and then you end up kind of there. I think a lot of folks will start as an electrical engineer, and they might go through the controls engineering path. Some folks might start in like the mechanical engineering or industrial engineering kind of route, and then you end up like taking a position and like learning through experience.
But those are the engineers. Like, what do you do for the technicians? Are there trade schools for this stuff?
Well, like there's the electrician side, there's like electricians that do that, and then there's like, electricity is electricity, like to oversimplify, but some of them kind of specialize in, like wiring up control panels and then designing the control panels. So a lot of times it's a kind of a handoff between like a controls engineer and like, that electrical team that might build it. I think panel design is a crazy thing, and I don't know how you get there from the other place.
So panel, so I think I think you and I are blurring the lines a little bit. So when I think about control technician, I'm thinking about someone who's actually integrating into the control panel, like on the DIN rail, actually plugging and chugging and wiring and all that stuff, right? And then, there's the person who spec'd it and designed the panel and did all the other stuff and like argued with me about the motor and like why we need.
Oh, I argue with those guys too. Yeah, the controls engineers. Yeah. Some of my like closest working relationships when I was a project manager were like controls engineers. Because you just have constant disagreements about like how to make the box go down the conveyor, and then you build a friendship from that, which is a crazy thing to say.
Well, I never made friends with them. I always thought they smelled a little weird, but that path makes sense. Like that's an electrical engineer or a computer engineer who backs into this career, which honestly I think is actually one of the cool paths you can take. Like imagine just staring at FPGA logic all day in a dusty like basement versus actually getting to touch hardware and build really cool stuff in big buildings. But anyways, but the technician thing, like how do you bridge that gap? That's what, like when I've had to hire in the past, like that's really hard. Like how do you find someone who knows what a PLC is and knows why 12 volt is significant versus 48 or like 5.
72.
Yeah, like but I mean, it's a problem, and that's something that I think China nails, and we don't. And I don't know what the solution is.
You can make more of them. All the ones that exist are pretty well employed. You know what I mean?
Like super employed.
And so, yeah, they're very much employed, and everybody's kind of holding on to them for dear life. Like they exist, but they're not like out there looking for work.
Well, you know what I've seen, and I don't like the solution, but what I've seen is they blur the line between technician and engineer, which I do think you should do early career. Like I think the first 5 years of your career should be you hitting the pavement, like getting shocked, like finding the magic pixie smoke inside of all the boxes and like learning something, right? But on the other hand, I think there's a point in your career where you should step back and start mentoring and start just cranking on the engineering side. So I don't know. I bring up the skill problem because I think people who are listening to this are probably like, yeah, I'm having to deal with that right now, and I don't know what the solution is.
I can't find a controls engineer. Yeah, so there's a bunch of our customers that will like put in like a large scale automation, and this is less true for manufacturing sites because they already have a pretty considerable engineering department most of the time. But for like logistics sites, they don't have a controls engineer on staff usually. So, some of them do. It's actually quite impressive when you meet a controls engineer that's on staff somewhere. But they have to build, like you put in an ASRS, right? It's robotic. It has a bunch of conveyors that feed and take away, and the process is very specific to that site. How do you maintain it? Like, where do you find the maintenance techs that know how these robots work? Where do you find the controls engineers that can reprogram something for you? Can you even afford to staff one controls engineer if you only have one building or two buildings, right?
Yeah, that was going to be a question for you. What do you do when a client comes to you and they're on the smaller side and they don't have the support? Like, if I came to you, if I'm in charge of eMoshco and I come to you and I'm like, hey, I want to put in a conveyor and this lift and this, what do I do on the back end when it's all integrated and finished and it breaks?
We spend any integrator worth their salt is going to have like a support department, and so like if you have one warehouse like eMoshco, right? You probably can't afford to have one person, but you could afford like a 15th of a controls engineer, and so in effect we're like fractionalizing like that labor. I'll send a 15th of a person to your site. So whenever you need 3 hours of support, I can have a guy log in, go VPN tunnel to your PLC, pop in whenever. Or if you need somebody that knows how to repair a robot, we'll have a guy go out there and repair it for you. Some sites are so big that we actually just like either the customer like commits to all the training because it's so much automation, which is not super common. But sometimes we'll just like send a technician out there. We'll have a technician in like a large, like Nashville's a good example for us. We have like a bunch of sites in Nashville where we're supporting, and we have a bunch of technicians and we can just move them around. So it's pretty straightforward.
What do you do when you have clients where you don't have a centralized location? Like if you've got a client in Montana and
that's tough. So like the bad answer is it gets more expensive. So we could hire somebody and train them and then send them out there. They just sit at this one site. Really? Montana's an excellent example, right? Yeah, it costs a lot of money, but like the alternative sometimes is like, well, how much would it cost them to figure out how to train this person and then manage the turnover? And then like, let's say you have one technician that you've trained, like when he goes on vacation and the building is still running, what do you do? Like there's 2 weeks of like just uncovered like chaos. And so like the integrator support side of it, like this is maybe like one of the less talked about but bigger benefits of having somebody help you put in like automation, is like they already hired all the people that are hard to find.
Yeah,
like,
exactly.
All the controls engineers I've met, like they work primarily for integrators.
Right. Well, that problem, and by the way, I saw this in the entertainment industry, like support. So for theme parks, support was exactly as you're saying, which is, okay, whenever this part breaks or this thing breaks, you call us, and for us, the unit economics makes sense where we just have I was going to say repository of people, call it that, I guess. But you've got a place of people, a stable of folk. You put them on an overnight and it makes sense because literally it's fine, right? But if you're running an operation where it's like 24 hours a day, you can't handle 24 hours downtime. So I don't know, that problem to me just seems like very difficult to manage for remote sites. So
It's yeah, it's kind of untenable. Like you want to run that much, and the other kind of the um, tangential like thing that makes it worse is that when you automate, you typically try to extend the hours of that operation as much as possible. So like the longer you can run, the less equipment you have to buy, and the lower the capital would be, and then that makes the investment better. But now you have extended operating hours in very many circumstances. So now you have to support it for more hours, and that's rough.
yeah, I'm curious. I'm curious to see if there are any alternatives enabled by quote unquote technology in the next 5 years. Like VPN, like that's something that has existed for a while, but that actually probably wasn't something that wasn't always something available. So that's a nice to have. But who knows? Maybe we'll get humanoid robots, and you can just leave. It's like, here's our Hy-Tek bot. You just leave him in the corner. He'll go out for a smoke once in a while, but just like let him be, and then
A little blue smoke. Yeah.
and just whenever something breaks, we'll walk him. He'll turn on and walk over to the thing and like help you diagnose. Like that'll be in the future, maybe. But
I think remote maintenance is like kind of a cool avenue. Like based on my experience with like AI customer support, I don't think we're there yet. I think we're
yeah,
so far away. It's not funny. Love getting on those calls. The voice is convincing enough, but like the response is not, and it really hurts.
yeah.
All right, so let me ask you this. You one thing I learned about you is like you like to design stuff, and I've talked to you in the past, and you've designed all kinds of stuff. You're actually the guy that's responsible for that viral send cut send video where it was like the part. It's like the most complicated. Yeah, that. So like we'll link it in the video, but it is wild. And then how did you come up with this idea? And then I'm going to ask you to talk me through how do you go about designing a process and then a product.
So yeah, the original idea for the part thing was I have a good relationship with the team at Send Cut Send, and they've been like just fantastic because if I don't like something about the service, they'll actually like listen to me and let me complain and make changes. So I just have a great relationship with them. So I just kind of one day said, "Hey, I'm going to do this thing. I don't think it's going to work, but it'll be fun for a couple days." And then it just exploded. People were just super excited to see day one, it looks like this, day two, it looks like this, day three. And keep in mind, a lot of the people that I interact with on socials are pretty much engineers. So for them, it's like, where is he going to go with this? It was, how much more complicated can it get? So it was just fun to kind of see the evolution of something just becoming more and more complex. I think for people, for me, it was just fun. But yeah, I mean, so that isn't a great example of like the design process. I think for me, the design process is like I know explicitly what I need. Actually, I would say the opposite of the part is the good design process, where you start with something super complicated and you try to boil it down to the simplest things, right?
Yeah.
And this is something I don't think a lot of industries understand. Like software engineers, for example, like you start with something that's basic. Actually, I don't. I'm only newly.
Start with base code to try to branch out versus starting with the end in mind and trying to pare back.
Yeah,
Is that the?
I shouldn't talk about software engineering. I don't know enough about it yet. My intuition right now is that it's the opposite. So instead, what I'll say is, I think there are many industries where this isn't true, but the best engineers break problems down into their simplest components and then attack those components. So for me, it's okay. I'm given a thing. Like I have a very complex thing that I have to do. And so it could be like, here's an iPhone. Like, okay, well, what does it need to do? Okay, it needs to have a screen, and it needs to have buttons, and it needs to have a camera, and it needs to have a battery, and yada yada. You go through it all, right? But the act of like
Mhm.
saying what it needs is the art, and that's where you make your biggest mistakes, or you get rid of your mistakes. And so, anyways,
Design requirements, right? Like generating the design requirements. Is that kind of the idea?
Kinda. I actually am anti-requirement. I can tell you more about that, but maybe the iPhone's a bad example. I think when you look at um, Yeah, I'm not going to go into organizations right now because I actually think that if you want to look at how to do it incorrectly, using the iPhone as an example is actually a good idea because you start to get into, I think it's Goodhart's law, but there's a law that says essentially you don't ship products, you ship organizations, right? So,
Okay.
like,
Yeah.
for instance, like if you look at a car, have you ever noticed how despite the fact it's 2026 and despite the fact that like phone screens and laptop screens have gotten great, you look at your infotainment system in your 2026 Toyota Tacoma and it's an actual disaster. It looks like it was designed 20 years ago. And like the infotainment system is terrible. It's because these organizations have literally existed for 20 years. And so for them, it's like, should we include an infotainment system? The answer is, well, of course, because we have an infotainment team and we have the electrical engineers in that team and the mechanical engineers and yada, yada. And we have sourcing and Dave. Like, we love Dave. We don't want to get rid of Dave. And so you can actually see it in cars. Like, they ship the organization, not the product. So when I talk about like designing things from the ground up, I should first say it's almost impossible at a large organization because by the time it gets to you as an engineer, it's been decided by the org structure. So just keep that in mind.
Yeah. Yeah. The process is going to influence how the product is.
Exactly.
Right.
Yeah. Like, imagine if every time you made a dish in your kitchen, you had 5 people whose jobs it were to like do certain things. Like, this is again, Dave cuts meat. Like, well, there go all the
Yeah.
vegetarian dishes because he cuts meat.
Yeah,
You know what I mean?
I think if you make the
So
same part by like machining or by casting, like it'll look the same. It'll fit in the same hole. It'll be a different product though. Like, they're fundamentally, like, the process makes a different thing. And I think, like,
yeah,
in supply chain, like when we design like building processes, like that is definitely true. And sometimes we try to dance around like, is this process okay? Is it going to change the condition of that package? Right? Is the package going to be faster? Is it going to be less damaged? Is it going to be in a better box? Like, the way we decide to do it, it's going to determine all of these things. I think I've never thought about that before, but now I'm having to think late in the day.
look, it's really frustrating when you learn it. So you'll actually not now when you go back to work, you'll be like, wait a second, do we actually need this? And you'll realize that, oh, we're doing this because like we just have this like requirement or test in our org. It has
Yeah.
nothing to do with the product. And I bet you if you go look at like all of your look through your product line and think about every single thing and everything it touches. And if any of them skip certain orgs, and you'll be surprised. I'll be very surprised if they skip any orgs. Like, yeah. Anyways, so anyways, I give that I say that first because you shouldn't be too hard on yourself if you're in a large organization. You're not really able to, invoke or enact the way you want to design stuff. Like, all the stuff I'm designing these days are essentially on my own. And so you have to be a part of a great organization to say something like, okay, you get to decide how you're going to design this and what you're going to use. Like, I've been a part of those teams. Like, when I was in entertainment, there was a company called Tate. They were like ground up. If you told them, if you could actually walk over to the electrical engineers and say, we're not going to use you on this project because we came up with a great way to do this. Like, I once saw a guy attach like thousands of pounds of counterweights to a thing instead of using complex electronics, and it worked. Like, it's incredible. You know what I mean? He's like, you know what? I'm just going to put 1,000 pounds here, and so that way, whenever someone steps on this thing, it's like counterbalance, and it's like that's. But see, that's the brilliance of something like that, but that's what brilliant design looks like. It's saying, here's like the way this works typically, but I'm going to throw all that away for a moment, and I'm going to look at this from first principles and really think about what I actually need to do. That's where great engineering happens, and it's also the most fun because you end up pushing boundaries in ways that you hadn't done before, and then you'll get to explore a little bit more, and yada yada yada. So anyways, it's a lot of talking about like generalizations around product organizations and processes. What I will say is you start with what you're trying to do. And by the way, this is so important. It gets lost. Like, how many projects you've been a part of where, I used to see this at Apple all the time, and it would kill me. Like, there's some test for a thing, right? And you have to do this test. And so no one knows why you do the test. But you have to do the test.
You got to do the checklist.
It's like, Yeah, this has to be submerged in bleach for 14 hours, and then we have to check to see that, whatever. Like there were tests like this. And uh but no one knows why, because people have only been there for 4 or 5 years. So there was some guy or gal 30 years ago was like, oh yeah, we got this one continuous complaint about the product, and it's because when you brush your teeth right before you use the phone, you end up like some gas gets whatever and like breaks the microphone, right? Um, and so uh, you fall into these ruts of thinking about designing to the process and not designing to the product. Um, and so I would see this all the time in large organizations. I mean, Apple was particularly bad about it. I think Amazon, I mean, you remember Amazon, it was like there was no
Yeah.
process. It was every time you walked into the front door, it was like doo-doo-doo-doo-doo, doo-doo-doo. That was like the Wild West thing. Like who knows what's gonna happen today?
No one did it. Yeah, and it was at the beginning of COVID too. It was a wild, wild time. You know
Oh
what's
my God.
funny is, now that you say
Wild.
that, I was working on a project a long time ago, and the customer brought out a pickle jar full of like random bits of like screws and scrap metal, and
Yeah.
they put it on the conveyor. And I was like, please do not do that. And they're like, no, this is a test. We always do this pickle jar test. I'm like, what? You, but why do you do this? Like, well, just to see if a pickle jar breaks. I'm like, you guys don't ship pickles. And if it fails,
Well,
it will be catastrophic.
if you look at the great CEOs and just operations people in organizations, they all have like common threads. They all say different things, but they all have these common threads. And one of them is, um, so Jeff Bezos said this, and I think he's 100% right on this. He said something to the effect of like, don't let process become the proxy for the product.
Yeah.
And in that case, that's a proxy, right? It's like we don't ship pickles, but we're going to put this thing on the conveyor because we've done it for 10 years, and that's the best way to test this. Well, like there's 10 assumptions in that, and none of them are probably true, and you won't know they're true until you question it, right? So really, the mother of good process is probably fighting against it as hard as you can. And so going back to your question from like an hour ago, what's my design process? It's find out deeply what the requirements or what the goal really, really is. Because when you get to that point when someone's like, oh, we're failing this pickle jar test, it doesn't matter if you're at Bob and Smith Co. in the middle of Montana or if you're at Apple, you want to ask yourself the question, well, why are we doing the test? Because first of all, you might not need the test. Like this is very important to understand. And so you start throwing away all your assumptions as much as you can. Now, the downside of this is that it's very slow, right? Because if you question everything every single time you do something, you're never going to get anything done. So the answer is like, you really do have to know what's important or not. And that comes with experience and having a healthy amount of skepticism for process and just the way things have been done before. And by the way, I think the most successful companies today are those which are the ones who have some dictatorial leader, which is who is absolutely sort of allergic to process. So start with the requirements, figure out what you really need to do, and then get after it. And usually getting after it is, and this is probably the best advice I can give anyone designing anything. It's true for if you're designing a conveyance system, a warehouse, a sort center, a robot, a stage, a phone. It's true for all of it. Start with the highest level requirement. So if you're at Anduril, it's like, okay, we need to design a UAV that can fly 10,000 miles without recharge or refuel and come back autonomously. Like that's your highest level requirement. Then you can tack on some things. For the iPhone team, it's okay, we need a glass rectangle that has 10% more new features this year. So we can still, no, I'm kidding. But you see where I'm going with this, right? Like you need to break down that super high level requirement, and then you can tack on okay, well, this too. Like, by the way, Suzanne from operations said we can't use this one machine process. It's like, okay, great. We have another requirement to add to the list. And then you just build that list. And I know it sounds so simple, but just start with that. Like figure out what the hell you're trying to do, because the process is so laborious and so painful and takes so long that if you don't write it down, you're just going to catch yourself in this endless loop of like, well, I don't remember why we did this, but or why we needed to do this, so we'll do that. But here's the beautiful thing. Here's like the really cool thing. If you write it all down as simply as you can and say, here's a paragraph describing what I'm trying to do, you can then break it down, and that's where the magic happens. It's okay. We have a roller coaster. Well, a roller coaster requires tracks. Okay, tracks. Got it. It requires cars. Okay, great. It requires, a frame, and and you see where I'm going with this.
Mhm.
And then,
Yeah.
then you have these master level assemblies, and then you can break those into sub assemblies. And by the way, this is like 100 times more valuable than not doing it, because you can see where I'm going with this. If you know exactly what you have to build, you can then know what you can take away and what you can add. And it helps you on the project management and the personnel side, because now you can say, oh, well, they all have this one, control layer. So I bet you Dave is going to want to have a say in like, oh, let's make sure it's all, let's make it all like A, B. That'll simplify it versus like having A, B, and whatever over here, right?
Yeah.
And so write it down, break it into the smallest components, and that's really like most of it, I think. And then after that, it's just grinding through the engineering. So
Yeah, interesting. Yeah, I always have found that like people that are some people get paralyzed by like starting that process, right? Uh,
yeah,
and it's almost universally true. Like just do something. I actually tell my kid this a lot now too. Like just do something. You're gonna screw this up, but
yeah,
then you'll know what you just screwed up, and you can fix that.
yeah.
And there's no penalty actually in real life for like screwing it up and fixing it in most circumstances. Just try something. And
Analysis paralysis is you got to fight it.
yeah,
People were. It was so funny watching a couple years ago. People take a bad stance against SpaceX blowing up rockets, but it's like, how else would you learn? Like you gotta go figure out where the smoke comes out, and then you can put tape on that.
yeah,
It's really that simple.
it's crazy to like are you gonna just launch it and get it first try like a skateboarder, like first try? Like, no, like that's great. And typically for skateboarders it's not even the first try. Like yeah, you gotta go out there and mess up a little bit. I think
Yeah.
it kicks off the iteration process. Okay, so let me ask you this. Do you see, and you've got both sides of the aisle here. Do you see any big difference in your design process when you go between like something that's process based, like a supply chain, like distribution centers? We're designing a process versus designing a product, like designing a phone. Like, do you see any big differences between those two, or is it just a semantics thing?
That's a good question. I don't know that the process is the product, I guess. In a way they're identical, because when you design a product, there's process there. Um, like when you as an example, like when you design an iPhone, you don't really design the iPhone. You design the iPhone and the process that produces the iPhone.
Yeah.
You know what I mean? Like you're actually going to China and,
And here's how the
sitting in a
cell is
warehouse.
supposed to work. That
Yeah, like you're actually walking the line and making sure that, okay, when I install this cowling in this order, it doesn't break this flex like that. You're also designing the process.
Mhm.
So when you design a mass-produced product, I would say there's a lot of overlap there. When you're doing prototype onesie twosies like you do in the entertainment industry, there is actually an element of like fire and forget, where okay, we ran our FAT and SAT tests, and we're handing this off to the client, and so like you forget about it. You have support, but you avoid that. So yeah, there's definitely a difference, and it depends on what kind of product you're building. If you're building a prototype, it's very simple. If you're building a mass-produced product, there is a process associated with it. So really, it's roughly the same thing. In the terms of approaching the two, you don't get to prototype in process development, do you? Like when you sit in front of like, okay, well, this conveyor is going to do this, and then this, this person's going to do this, and I have this thing. Like you have to kind of rely on sim, because you're not going to go build a prototype facility, are you?
well, sometimes we do. I always thought that was this interesting thing where like people say you can't test it or you can't prove it works. Well, we could do something very, very similar. So you can build a lot of proxies And some of our equipment's kind of modular, but the cool thing is if you find a way to do it, the number of samples that you can get for almost no money, like if you figure that out, is like almost infinite, right? So like making a prototype product and testing a few of those, they could be very, very expensive. But in my circumstance, like I need to make a new workstation, a picking process from a workstation. If I find a way to proxy that, like I can get 5,000 samples for like nothing. Like the R&D engineer that I've had do that is not going to be super pleased, but I mean, sorry, Jesse, like I need you to do one more cycle.
Well, but so you can do some testing. Like you can do some prototyping, but not like at the scale of the.
You'll never build the whole thing. Like I think that, and that's sort of getting to your point. Like the thing so we do a whole building, right? Or maybe like it was one of those sort centers that you and I worked on together. Like you can't just build one and see how it goes. Like that's in essence, that's sort of what they ended up doing, right? And then they had the next version, let's tweak it. But you have to have a unbelievable amount of capital to kind of get away with that, and no one else does that.
No one's gonna, but you can't even really prototype it. The prototyping is like you just build it and you have a crappy version of it until you improve it next time, which I think is what the big.
I think there's plenty of warehouses out there that are that.
Oh yeah.
Yeah. So everybody wants to avoid like that. I think I actually had one customer say that it was a larger company and like they were very mature about how they approach automation and process design and building improvement. They said, listen, this is the first pancake. And I was like, oh, I love pancakes. What does that mean? Like, you know how you always screw up the first one? They just kind of like mentally prepared themselves for the first pancake. And then like when they start going into the second project, like they're doing some cutting edge stuff. Like this customer's like very progressive in how they approach automation. When they go to the second one, they already know everything. And none of their competitors have made the first pancake yet. So like nobody else knows how to do this.
Tell me, Joe, do I get first pancake pricing though? Because
it turns out if you ask really nicely, like some people do get first pancake pricing. Like this one's
Are we allowed to speak poorly of your competitors?
Like, I personally can't, but listen,
can you blur this out? Can you blur? Can you bleep out what I'm about to say?
Yeah, we can do some bleeping, I think.
There was no first pancake pricing. They would come out and ship just a load of horse and just be like, okay, you want us to fix this? We're going to charge you $1 million for a change request because we messed it up the first time.
Oh, you want electricity in that? I guess that was an email.
Oh, it's $1 million.
Bro, well, yeah, it's got motors.
So I guess what I'm trying to get at is like, maybe you don't need a discount, but you do need to be a type of company that's like, all right, yeah, that was on us. Like we should have caught that. You know what I mean? Like there has to be a good relationship there for that to kind of work.
Yeah. Like you need to trust your partners. You need to give them the leeway to like make the changes they need to make. And if you can make that exchange not hostile the entire time, the end result is significantly better for everyone.
I've never worked with a partner who was so actively hostile. It was like they were told, like if your client likes you, you will be fired. Like that, it felt like that was actually a mission.
Don't get too close.
Yeah, it was so bizarre. Maybe it was just the project managers we were dealing with, but man,
project managers is hard, man. You do it for too many years.
I know, but I'm genuinely saying this. I've never in my entire career had such an adversarial relationship with the vendor, and I don't understand it at all. Maybe it was because we were, you know what position we were in. It's like, I kind of get that, but I don't know.
It's King Kong fighting Godzilla at a certain point, like.
Yeah, and we're just like the people on the street who are getting stepped on.
Yeah, exactly.
That's kind of messed up.
Do not go in that tall building.
Oh man. Yeah. If you want to work on big capital projects, you need big capital money. So can't complain too much.
Yeah, absolutely.
So I hope that was a good answer. There are definitely nuances there, but I think the start of the project is the same of like find the thing you're really trying to solve and then solve for that. Which, by the way, a great book you recommended to me was I can't believe I didn't read it until I was in my 30s, but The Goal.
Yeah, dude, you have to read The Goal. 100%.
Well, when you read that book, you realize, oh, everyone's just doing that. like all the really good people have read that book, because it
Yeah.
really is just as simple as like, okay, what is the slowest thing? That's the thing you solve. And by the way, if you go look at like people are amazed by Elon Musk's like running of his companies, but he literally is just implementing that book. It's like you have a giant company. There's one thing slowing you down. Find that one thing this week and then fix that. Another thing will appear. But if you just go through that loop, it's super simple. Like any dummy can do it. Right?
All the good
Now,
Satisfactory or Factorial players, that's how they play that
exactly.
video game. Like all the good like process engineers or ops managers, like that's all. They just, you find the one thing and it has this like really long lever on it and you just crank it. Yeah, it's once you know the secret, it's cheating.
I think there should be required reading. So you know how at Harvard Business School they force the MBAs or whatever to read like 5 books or something, and one of them is like Sun Tzu's The Art of War. Did you know this?
They should substitute that. Yeah.
No. Let them keep reading that stuff. Like whatever. But I'm saying for engineers, there should be 2 books that you should be forced to read. One is The Goal, for sure, and the other one is The 48 Laws of Power. Not because you should do what's in the book, but so that you can identify a loser who reads that book and tries to manipulate other people. That way you can go, that guy's a loser or that gal's a loser. I saw that's law 42. Like that is a loser. Like fire them immediately. Like, you know what I mean? So one is like how to actually run an organization. And the other one is like how to look for people who are going to ruin your organization. And I've worked with those people and you don't want to work with them because it is.
All right.
Anyways. But by the way, that book is very popular.
Yeah, you're
so
now on
I
the
should
list.
be careful on
but the goal people will back you up.
I'm on a list. It's incredible. And it's funny. I'll never forget that. What a great book recommendation, Joe. You've actually 2 of my favorite books, the Project Hail Mary.
And then Dune.
You recommended that to me too.
I know you've already read it.
Come on. Come on. Really?
You haven't read Dune?
No, I haven't read it. I refuse to read it.
Well, the first
movies are so good.
But it made me want to go. They made a movie. I had to read this book because it can't be this bad. Then they fixed it. They came back around. They got it done.
Topic of industrial automation, but
we're way off.
But Dune might be one of the major renaissances of art in American culture. It is so, and it's funny. The first time I watched it, I was like, this sucks. I hate this. And then my wife watched it and finally she's like, you have to watch this. And she was right.
Yeah, Frank Herbert was a genius and he was ahead of his time.
Wasn't it hard to get that book sold too? Wasn't it like some random it was like a motorcycle maintenance. No, it was a car maintenance, manual maintenance company. It was like, yeah, we'll publish this. They never published fiction before and they just did it. I think. Really? I think it was Dune.
Yeah, man, it's just interesting. I'm going to try to tie it back together. But the use of technology in that book is different than most sci-fi books. And in that, the way they describe technology is almost timeless, right? Nothing outdates, right? Now, the physics of it don't make a ton of sense. But yeah, they've described this beautifully designed world where stuff works a very specific way and everybody knows the rules and everybody knows the processes. And it's just, it's at odds with every other writer in that same genre, I think.
Did you watch the movies?
Yeah.
Okay.
Bro. Yeah.
The first one? Did you watch I forget his name.
I watched the old one where the fat dude's floating and you're like, this is the worst practical effects I've ever seen.
He did Twin Peaks. What was his name? I love him. He actually was embarrassed. That's his great failure. He wouldn't even talk about it in public. And by the way, that's actually, we can tie this back to automation if you want.
Okay.
All right. First, we have to find his name. I cannot believe I'm forgetting his name. There's a shrine to him at my favorite brewery in town, which is funny. He just passed away too. He's such a interesting, good dude.
We're good.
David Lynch. Duh. David Lynch. I can't believe I forgot that.
Oh, David Lynch. Yeah. Okay.
So David Lynch actually, he really wouldn't talk about it after the fact, and. I think there's a lesson in the first Dune. Buckle in. I've learned from it. If you take the job of the artist And by the way, I actually consider engineers artists. So this,
I think that's very fair. Yeah.
I mean, how else?
The good ones are.
How else would you? Okay.
Yeah, it's visually pleasing.
And useless.
Requires all the engineering skills.
Yeah.
Yeah.
I can't wait to walk into
The
a
whole
meeting.
purpose is the art, right?
Yeah. So actually, and it's funny. Maybe the product is not art. Maybe it's the process. Yeah, I like that. Because the way. So by the way, and I'm going to plug this at the end if you don't mind. I have my startup, which I want to talk about. But engineering is an art, I think, because you're willingly forcing into the world something that didn't exist before. Like even if it's a copy and paste job, it didn't exist before, right? So you might be bordering on the craftsman side, but there's still something there. Like I think a lot of engineering is art. And anyways, so when you look at what happened with that movie, it's actually the tale that every engineer knows, which is you start with a lofty goal or ambition, finance gets involved, the operation team gets involved, and what was once this beautiful thing you loved is now just like this weird mess of slop on the floor.
Compromised.
Yeah, and everyone no engineer has ever shipped something they're totally proud of, right? And I think Dune is the extreme version of that, where the meddling from the operations and finance folks was to a level that, if he wasn't contractually obligated, I'm sure he would have walked, or maybe he thought he could, maybe he didn't learn the lesson and did with that movie. But, it's just a reminder that part of your job is not just creating a thing, it's like sheltering it away from people. They're not malicious, right? Like, I don't think Tim Cook is ruining Apple on purpose. I think he has a very specific skill set and he's doing what he knows to build that company. And it's worked well. Like it's almost $2 trillion company now, like, right. But if you look at the products, it's like, did I love my first MacBook Pro more than I love this one? Actually, the MacBook Pros are the one product that for some reason magically get better at Apple. Always.
They're quite solid.
But yeah,
it's like everybody's doing the right thing, but you don't get the result that you would expect from everybody doing the right thing. And I've seen this happen a bunch of times, and it's like always this. It sneaks up on you.
Yeah.
I followed all the processes, and then you just get this
And by the way, that's part of your job. Is like you have to shelter. And if you start looking around, you'll meet engineers who are like, okay, we're gonna do it this. We do it this way. And we're going to make sure that we kind of like loop this person in at the right time, right? Because they've been bit before. They know like, okay, we're going to focus too much on this problem instead, right? Like the really good engineers know how to figure that out. And I be careful there though, because quickly that can turn into professional politicking instead of engineering. And you have to be careful, like you're doing just the right amount to make sure that the product survives, but not making it your job, which at a lot of companies is. So anyways, that's how Dune and industrial automation are roughly the same thing. Thank you for coming to my TED Talk.
Beautiful. Emmanuel,
can I plug?
Thank you very much, man. This is definitely a different type of podcast, and I like how this played out. I've not gotten to talk about Dune in any of the other ones.
Good. Can I plug first before we sign off?
All right, hit it. Plug it hard.
If you are doing engineering, or you are doing any type of engineering documentation, or really use Excel at all, please use my startup's product, which will be coming out in a couple weeks. You can find it at get2workwithac.com. So get2 WORC, not K, C.com, and use my startup's application. It will mean a lot to me if you do. Thanks, Joe.
All right. Awesome. Thank you, Emmanuel. And for everybody following along at home, this has been the Automation Insider. And subscribe anywhere that you listen to podcasts normally. See you next time.
Bye.